Today, I shall elucidate the Tetris game I made using the C# programming language. The principal aim of this initiate is to elevate my proficiency in the C# programming language, coupled with a systemic execution of in-depth insight into the tenets of object-oriented programming. I will show the code's comprehensive structure. The program can be dissected into two fundamental components, the Tetris background and the Tetris blocks. The blocks are involved with movement constraints determined by the background, generating new Tetris shapes randomly when they make contact with the background floor. Moreover, upon completing a line, the corresponding line vanished, giving rise to a fresh empty line. Now, let's see the code. The Tetris project is composed of 5 classes, including the programming class. Let us commence with the programming class, which constitutes the game screen of the project functionality. The execution of the programming unfolds in accordance with the order of the code encapsulated within this class. Initially, the programming class invokes other classes such as Tetris screen and block. Subsequently, a while loop is employed to sustain the continuous movement of the Tetris block. Within this loop, methods such as the thread sleep method help to users see automatic descents or movements of the block with right time. Clear servers to erase prior terminal contents and bespoke functions from other classes govern the block's movements. Moving on to the next class, the X-Screen class, responsible for interfacing screens and blocks in Tetris games. This class streamlines the code by inheriting common contents from the Tetris screen, adhering to object-oriented programming principles. The render function responsible for defining the dimensions of the entire game screen in the parent class is overridden to convey the block's motion on the screen. Additionally, a discrete check function is implemented to ascertain the completion of the Tetris block, removing the line and introducing a new blank line at the top. Transitioning to the parent class of access screen, the T-screen class, a list structure is implemented to store information along the x-axis and y-axis. Functions such as x and y are deployed to relay information to the access screen child class. Subsequent function handle Tetris input on the board, read the path of Tetris block movements, and generate the actual game screen. Let's see the last class, block. Concluding the exploration with the block class, it's noteworthy that the block class and block data class are essentially identical. This means those two classes are same one class. The division into two classes serves the dual purpose of preventing code color for readable preservation and adhering to object-oriented programming principle. In the block class, code pertaining to block movement based on user key inputs is implemented. Meanwhile, the block.data class is responsible for manage data related to block shape. An important feature within the block class involves the display of the Tetris screen. However, this value is initially set to null. This design choice arises from the separation of the block and screen fundamentally into distinct areas. Specifically, a separate block layer exists on the top of the screen layer, allowing for independent block movement while the screen remains static. It is crucial to recognize that this separation does not imply the entire dispersion state. The permissible block movement area aligns with the dimensions of the background. The data accumulated on the block surface must be stored within the background. Consequently, instead of loading an entire new Tetris screen, we have chosen to initially assign a null value and subsequently populate with data, ensuring seamless integration with the existing screen.